Hi guys, my name is Nandan. I'm a second year CS undergraduate pursuing BTech in Bennett University. So today I'm going to explain you about bucket sort. Hi guys, today we're going to discuss about bucket sort. So without any further delay, let's dive into the video. Table of contents: introduction, working, algorithm, time complexity, advantages, disadvantages. In this session, we're going to discuss each and everything in detail in this video. So first of all, what is bucket sort? Let's see. Bucket sort is a sorting algorithm that works by distributing the elements of an array into several buckets. Each bucket is then sorted individually either using a different sorting algorithm or recursively by applying the bucket sorting algorithm. It is also called as bin sort. It is a distribution sort, a generalization of a pigeonhole sort that allows multiple keys per bucket and is a cousin of radix sort in the most to least significant digit flavor. The computation complexity depends on the algorithm used to sort each bucket, the number of buckets to use, and whether the input is uniformly distributed or not. Why is bucket sort important? Bucket sort gives product teams a way to focus development and resources on the most impactful projects and initiatives that will delight customers and create a competitive advantage. However, it still allocates development time to other projects and initiatives from the backlog. Let's see the working process of the bucket sort. The bucket sort works as follows. First of all, I have to set up an array of initially empty buckets, and then we have to scatter, where we have to go over the original array by putting each object in its bucket. And then we have to sort each non-empty bucket. And at last, we have to gather, where we're gonna visit the buckets in order and put all the elements back into the original array. In this way, bucket sort gonna works. Let's see more examples in order to know bucket sort working process well. Example 1. In the given array, we can see like all the elements were unsorted. So in order to sort by using bucket sorting, let's see how we're gonna run the process. First of all, we have to scatter all the elements into the necessary buckets. If you observe the buckets, they were assigned certain size, a certain range, that is 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25. And each of the elements were assigned within the particular array. For example, if you take 0 to 5, the first one, like as the one is in between 0 to 5, it was assigned to first one. And if you take 5 to 10, as 9 and 8 were between in that range, they were assigned in the second bucket. In this way, we're gonna uh, sort each and every elements according to the ranges. And after scatter, we're gonna start sorting as all the elements in the buckets were unsorted. You can see all the elements were now in the proper order. So after sorting, we're gonna gather at last. In the gather, what we're gonna do means like we're gonna combine all those elements which were present in the buckets in order to get the final output. If you see the final output, it is 1, 8, 9, 11, 12, 13, 17, 19, up to 24. It is clearly a sorted array which was in the ascending order. In this way, buckets are gonna works. Let's see another example for more understanding. Example 2. In this one, we're gonna cover decimal problem. So according to the previous problem, the input array was given, which is unsorted array. Like we know, we're gonna scatter the each and every elements in the array into buckets. As the elements which were present in the buckets were unsorted, what we're gonna do? We're gonna sort. We're gonna sort all those elements which were there in the bucket. After sorting all those elements which were there in the buckets, we'll get some output. And after that, we're gonna gather all those elements from the buckets. In this way, we will get the final output array. If you're gonna see that one, it's 0.6, 1.9, 3.04, up to 10.1. It is clearly in the sorted way. In this way, bucket sort gonna work. Coming to the algorithm of the bucket sort. First of all, we have to create n buckets, and for all the buckets, we have to initialize the bucket value with 0. And after that, we have to push elements into the buckets which will match the range. And after that, we have to apply sorting elements of each buckets. And at last, we have to gather elements from each bucket which will be concatenated list. In this way, bucket sort algorithm gonna work. If you see the 5 and 6 step, the time complexity will be O of n, and the time taken for 7 to 8, it will be O of n log n by k. And for 9, it is O of k. If you're gonna sum up all, we will get O of n if k equal to theta of n. Time complexity of bucket sort. The time complexity for the best case is O of n plus k, and the for worst case is O of n square, and for average case is O of n. And the space complexity for bucket sort is O of n plus k, which is same as the best case. And as it is stable, we're gonna simply say as. Let's know how this entire best, worst, and average case came. Coming to the analysis, worst case analysis. The scenario where every element is stored in the same bucket is when the worst case in terms of complexity actually happens. In our case, since we are using the bubble sort algorithm to sort each bucket, the worst case would occur when we have to first loop over n items in the input array. And since all of them will be stored inside the same bucket, the worst case of the bubble sort algorithm would be come into play as well. We know the worst case time complexity of the bubble sort algorithm is O of n square, which occurs when the elements in the array or list are stored in the reverse order, and hence the total number of comparisons needed will be n square. Therefore, we will get a total runtime of O of n square. In this way, worst case analysis will be done. Let's see how the best case analysis was done. The best case in bucket sort occurs when the elements are distributed in a balanced manner across the buckets. That is, the number of elements spread across each bucket are identical. It can get even better depending on the sorting algorithm that you use to sort each bucket individually. You can even use different sorting algorithms for different cases. If the elements stored inside the bucket list are already sorted somehow after partitioning, the complexity will become even better. Once again, we will have a complexity of O of k for assigning and pushing the elements onto the bucket list, and a complexity of O of n for the sorting the elements inside the bucket list. Hence, we will get a total runtime of O of n plus k. In this way, we will get a best case analysis. Let's see average case analysis. The average complexity for bucket sort is O of n, and the average case occurs when the elements are distributed randomly in the list, and bucket sort runs in linear time in all cases until the sum of the squares of the bucket size is linear in the total number of elements. Let's see the space complexity as well. The space complexity for bucket sort is O of n plus k, where n is the number of elements and k is the number of buckets. Hence, the space complexity of this algorithm gets worse with the increase of the size of the input array and the bucket list as well. In this way, time complexity analysis is done for the bucket sort. Let's move to the next part. What are the advantages of bucket sort? Bucket sort allows each bucket to be processed independently. As a result, you will get frequently need to sort much smaller arrays as a secondary step after sorting the main array. Bucket sort also has the advantage of being able to use as an extremely external sorting algorithm. If you need to sort a list that is too large to fit in the memory, you may stream it through RAM and split the contents into buckets which were saved in the external files. And then you have to sort each file separately in the RAM. And also if the array, if the given input is of small and it is within the range, bucket sort will be the most preferable one as it is easy to implement. These are the advantages of bucket sort. Coming to the disadvantages of bucket sort. The problem is that if the buckets are distributed incorrectly, you may wind up spending a lot of extra effort for no or very little gain. As a result, bucket sort works best when the data is more or less eventually distributed, as we discussed in the advantage, or when there is small technique to pick the buckets given a fast set of heuristics based on the input array. And we can't apply to all data types since a suitable bucketing technique is required. Bucket sort's efficiency is dependent on the distribution of the input values. Thus, it's not worth it if your data is closely grouped. And in many situations, you might achieve greater performance by using a specialized sorting algorithm like radix sort, counting sort, or burst sort instead of bucket sort. And bucket sort's performance is determined by the number of buckets used, which may need some additional performance adjustment when compared to other algorithms. These were the drawbacks of the bucket sort. That's it for the video, guys. Hope you enjoyed it. Please don't forget to like and share the video. Thank you. Nandan signing off.